Okay, so here's a concavity question. We're going to determine the concavity and find the points of inflection of this function. And then we're going to look at the calculator just to make sure we're correct. So we're going to have to find out where the second derivative equals 0. That's the first. And this is the second. So now we need to set this equal to 0. So we're going to factor out a 4. So now we have where 3x squared minus 1 equals 0. So 3x squared minus 1 equals 0. Add 1, divide by 3. Square root both sides. Do not forget you get a plus or minus. And since the square root of 1 is 1, we can simplify it as plus or minus 1 over the square root of 3. Now that's a very uncomfortable looking number, but remember the square root of 3 is between the square root of 1 and 4, so it's 1 point something. So just realize that this number is less than 1. So the problem with this is going to be these numbers are very close to each other, but it doesn't matter because we can just use 0 in this interval. So anyhow, this won't be as bad as it looks. First interval, second interval, last interval. So even though we don't really know what negative 1 over root 3 is, it doesn't matter. We can use just a really big number if you want. Here I'm going to use 0. That's obvious. Second derivative. And here you can, again, use a really big number. If you plug negative 100 into this derivative right here, negative 100 squared is huge. So this is 4 times a positive. That means we're concave up. If you plug in 0, you have 4 times 0 minus 1, which is negative, concave down. And if you plug in 100, you'll get the same thing as when you plug in negative 100, because you're squaring it. So now we can say we're concave up on the intervals negative infinity to negative 1 over root 3, and then again from 1 over root 3 to infinity, and we're concave down on the interval negative 1 over root 3 to positive 1 over root 3, which means since concavity changed here and here, those are points of inflection. So we have a point of inflection at negative 1 over root 3, comma, and 1 over root 3, comma. We have to find the other point. Now that's the point on the original graph. So let's work on plugging those numbers into that and see what we get. I don't think it's going to be that bad because we're raising to the fourth. Sorry about that. I didn't realize I was off the camera. So those were our x coordinates. We need to plug them into the original function to find the y coordinates. So the one thing we have going for us is one's a negative, the other's positive, but we're raising both of them to an even power, which means they're both going to turn out to be positive. So this answer and this answer are going to be the same. So you only have to do it once. I'm going to do it with positive 1 over root 3. Now, 1 over root 3 to the fourth is 1 over root 3 times 1 over root 3, which is 1 over 9, times 1 over root 3 times 1 over root 3, which is 1 over 9. No. Sorry, I was way ahead of myself. 1 over root 3 times 1 over root 3 is 1 over 3, times 1 over root 3 times 1 over root 3 is 1 over 3. Again, you're just multiplying 1 over root 3 times itself 4 times. That's how I'm choosing to think about it. If you want to write it out, go ahead. So 2 times 1 over root 3 times 1 over root 3 is 1 over 3. So we have 1 over 9 minus 2 over 3, which is 1 over 9 minus 6 over 9, which is negative 5 over 9. Now that was a very messy problem, so I'm going to want to check. Now it's hard to get an exact check on points of inflection, but we're going to do the best we can. There's the graph. My zoom looks out of whack, so let me zoom standard. Whoa. Now, the points of inflection, it goes from concave up to concave down about right here. And then it goes from concave down to concave up about right here. So I'm going to use, it looks like I'm right. That looks like the points we have. But let me hit the value, second calc, value. I'm going to use that first x value of the point of inflection we had, which was negative 1 over root 3. Now, we've calculated that to be, so I'm doing this right here, negative 5 over 9. So let's just make sure the decimals agree. And then it looks like a point of inflection. So I'm going to hit enter here. You see where it drew my point? That looks like it's a point of inflection there. And it says the y value is negative 0.55 repeating. Hopefully that's what negative 5 over 9 equals, negative 0.5 repeating. If you don't know that off the top of your head, just type it in. That's negative 0.5 repeating. So that looks good. So this, I'm satisfied with my check here. The next one I show you, I think is going to be a trig one. So stay tuned for that.